All right, so like I said, arithmetic sequences are when you're adding the same thing every single time. So it's a certain type of sequence. The thing that you're adding is called the common difference. Okay, the common difference can be found lots of different ways, but you can do like any term minus the term before it. Sorry, that's supposed to be an A. So you can do A2 minus A1, or you can do A3 minus A2, or A4 minus A3. It doesn't matter. Any term minus the term before it. So personally, if I'm finding the common difference, I don't do that formula. I don't say like this term minus the term before it. What I do is if I see the sequence like 7, 3, -1, -5, -9, I say, how do I change the 7 to get to 3? What do I have to do to it? I subtract 4, right? And then I subtract 4 and subtract 4. That ends up being the common difference. Do you see how that works? If I use like the formula here, if I said A2 minus A1, A2 would be 3 minus 7. I get -4. It works the same way. Okay. So basically, I just say, how do I adjust? How do I move from one thing to the next thing? I subtract 4. That ends up being the common difference. So yes, it's arithmetic because I'm always subtracting 4, subtracting 4, subtracting 4, and D in this case is -4. Okay, if I was adding 4, then D would be a positive 4. So it says find a formula for the nth term of the arithmetic sequence whose common difference is 2 and whose first term is 7. So if I start with 7 and the common difference is 2, that means that I'm adding 2 each time. Adding 2, adding 2, adding 2. So I'm going to have 7, 9, 11, 13, and so on. Okay, so we want to find some kind of formula for this. Okay, so this is when you really have to kind of think about the process that you're doing. So be smart, think about what we're doing. So we're starting with 7, and if I want to get just the second term, I just add that common difference one time. That's how I got 9. But if I want to get the third term, I start with 7, and I add that common difference, right? 1, 2 times. I call these swoops. I have 2 swoops to get to the third term. Do you guys agree? If I start with the first, I add 1, 2 to get to the third. So I have 2 times 2. If I want to get the fourth term, I had 7, and I add that common difference of 2. I add it on how many times? 3 times. And if I have the fifth term, I add it on 4 times. In the sixth term, I would add on 5 times, and so on. So if I want the nth term, how many times do I add that common difference on? Nth. No, not 2n. Yeah, what do you think?
Huh? A and n minus 1.
Oh, is that what you're saying? 2 times n minus 1? I gotcha. Yeah, you added on n minus 1 times. I gotcha. I thought you were saying 2n minus 1 times. I was like, no. Okay, so here's what we have. So we have 7 plus 2 times n minus 1. So this ends up being, if you simplify your formula, 7 plus 2n minus 2, which is 5 plus 2n, or 2n plus 5. And then we can always check. We can see if that works. If I plug in 1, I have 5 plus 2, right? It's 7, so that worked. If I plug in 2, I get 5 plus 4, which is 9. If I plug in 3, I get 5 plus 6, which is 11. So it seems to work, right? So that is your formula. And that's exactly how these arithmetic sequences always work. You can start with the first term and you say, oh, I'm going to add on n minus 1 swoops. Okay, so that's the formula. So it says if we have the nth term, I start with my first term and I add on n minus 1 swoops, common differences. Okay, but the problem is a lot of teachers, especially in this area, when I do a lot of tutoring, I have students that come in and they only know how to do these problems if they have the first term, because this is what the formula says, right? It says start with the first term. But you need to be smarter than the formula. You need to know how to go from things like the 20th term to the 30th term, right? You need to know how to relate things given the 2 terms that you have. So in this case, D is the common difference, A1 is the first term. So I said, do not just memorize this formula. You need to know how to start with any term, not just the first term. So this is really a process that we're learning, okay, not just a formula. So it says find the 6th term of the arithmetic sequence that begins with 15 and 12. So if I have 15 and then I have 12, I can easily tell what my common difference is. What am I? How am I changing 15 to go to 12? I'm subtracting 3, right? So my D is -3. Okay, this is not a hard problem to do without any formulas. If I asked you the 6th term, you would be like, okay, well now I'm going to have subtract 3, I'm going to get 9, subtract 3, I get 6, subtract 3, I get 3, and then I get 0. That's the 6th term. Okay, easy, no math done. But I don't ask for the 6th term on the test. I'm mean. I ask for things like the 1,000 in first term. And if you do that, it's going to take you the entire test to do one problem. So I had a girl a few years ago, it was Izzy Ticketjohn's older sister, Lily, and she was like, I just feel so much more comfortable doing it this way, like just subtracting 3. I know I'm right when I do it that way. And I told her, I said, I'm going to put the 1,000 in first term on the test, and I did. And she got an A. She still knew how to do it, but she just felt more comfortable doing it like the way you do in elementary school with sequences. Okay, so let's go ahead and let's write the formulas. If I did this with a formula, here's what it would look like. If I want the 6th term, I can start with the first term, and I can add my common differences 5 times. It's like 5 swoops to get there. Does that make sense? So the 6th term ends up being 15 plus 5 times the common difference, which is -3. So I get 15 minus 15, which is 0. So same thing, just with the formula. You're talking about how many, like, I call them swoops. So if you start at A1 and you're trying to get to A6, you need 1, 2, 3, 4, 5 swoops to get there. All right, so the next one says find the 20th term of the arithmetic sequence that begins with 2 and 9. So if I have 2 and 9, each time I'm adding 7, so my D is 7. So if I want the 20th term, I say, okay, I'm going to start with my first term. And how many swoops do I add on? 19 of the D's, of the common differences. So my 20th term ends up being 2 plus 19 times 7. 19 times 7 is it 133, I believe? 2 plus, yeah, 133. So I get 135. So the 20th term is 135. Okay. But this next one is, we don't have the first term. This is what I was saying. People that I tutor around this area have no idea how to do this because their teachers have never shown them this. So this is on the SAT. Like, you need to know how to do these problems. Okay, so it says find the 5th term of the sequence is 190, and the 10th term is 115. Find the first term of the sequence. So whatever you're given, in this term I was given the 5th term, A sub 5, and the 10th term, 115, we always have to write an equation using whatever we were given. So write an equation using what you were given. So can we relate the 5th term to the 10th term? And we can. So if I'm trying to get to the 10th term from the 5th term, so I start with the 5th term, how many swoops do you think I would need to add? I heard someone say it. It's actually 5. And everybody, every single year will say 4. So don't feel bad if you said 4. Because everybody thinks, oh, it's n minus 1. It's not what I think it's going to be. It's not 5. It's 1 minus that. It's going to be 4. And it doesn't actually work that way. So if you draw your little lines, I'll show you why. So this is the 5th term. 6, 7, 8, 9, 10. This is the 10th term. I would need 1, 2, 3, 4, 5, right? It makes sense, 5. So let's look at our subscripts from before. If I wanted to get the 6th term, I had a subscript of 1 and I added 5, right? 1 plus 5 gives me 6. If I had 20, well, let me do it on the whiteboard. If I had the 20th term, I had a subscript of 1. I started on the first term and I added on 19. 1 plus 19 makes 20. Does that still work here? 5 and 5 make 10? Yeah, it works. So you're really looking at subscripts. It's kind of like that book example I talked about yesterday, like if you're talking about the pages in the book. If you're starting on term 1, right, not term 0, right, it's really only 19. So it gets a little bit confusing, but go ahead and just look at your little subscripts. That's why I always say write the equation. I always write this type of equation first. Okay, so my 10th term. So my 10th term is 115. My 5th term was 190 plus 5 common differences. I subtract my 190, so I get negative 75 equals 5D. Divide by 5, I get negative 15 equals D. Once you have the common difference, figure out what you need to find. It says find the first term. So it's the second part of the problem. So I need to find the first term. I can use either the 5th term or the 10th term. It doesn't matter. Which term would you use? Would you use the 5th or the 10th? to find the first term? I'd probably use the one closer to it. I'd probably use A5. It's probably going to be smaller numbers too. So I'm going to say A sub 5 equals A1 plus, so how many differences would it be? So I'm going from the first to the fifth. I need 4 common differences. Do you guys see? Because it's the subscripts that you're worried about. To get from the first term to the fifth term, I need 4 swoops. Okay. All right, so my fifth term was 190. I get A1 plus 4 times negative 15. So I have A1 plus negative 60. So I add the 60 over. So I get 250 equals A1. So the first term is 250. Okay, makes sense? Alex, you with me? Yeah. All right, so let's try another one where we have 2 terms, not including the first term, and we're trying to get another term. Okay, so you guys can try this one first if you want. So you're given the 7th term and the 27th term. So A sub 7 is equal to negative 5, and A sub 27 is equal to negative 125. So write an equation that relates the 7th term to the 27th term. So write some kind of equation. Yeah. Okay, so we write the equation connecting the 7th term to the 27th term, and I think all of you guys as I walked around have that. So if you start with the 7th term, you add on 20 common differences to get to the 27th term. So I usually try to keep it really consistent. I keep the bigger subscript on the left, and then I have the smaller subscript plus the number of swoops to get that bigger subscript. But it's okay, you can do it lots of other ways. A lot of people like to start with the bigger subscript and subtract out the common differences to go backwards, right? If you want to do that, whatever you want to do. Okay, so A sub 27 is negative 125 equals negative 5 plus 20 common differences. Be really careful with your signs. You're going to add 5 and add 5. So when you do that, you get negative 120 equals 20D. So D ends up being negative 6. Did everybody get negative 6? Okay. So then the second part of the problem says, well, we're going to find the 18th term. So if I find the 18th term, I can use either one. I can use the 7th term or the 27th. So let's say I do the 7th term. So I have the 7th term plus 11 common differences. See how writing that formula can kind of organize your thoughts, right? So the 7th term is negative 5. The common difference was negative 6. So when you find the 18th term, you get negative 71. So negative 5 plus negative 66. Did you find like the first term or something?
Yeah.
Okay, I see. I was wondering how you guys both had the same thing. Okay, so number 5. So it says, suppose you have the sequence 12, 18, 24, 30. What term is the number 96 in the sequence? So it's saying like we have this sequence and we want to know if we have 96, we want to know what n is equal to, what number it is in the sequence. So you could probably, do it on your fingers or whatever. It's really not that bad. But let's see how to set this up with a formula. Okay, we're going to use that basic formula that I told you that we don't really need to memorize. We just kind of need to know this process. If I want the nth term, I can start with the first term, and I can add on n minus 1 common differences. Okay, so my first term is 12. I have n minus 1, and then my common difference in this case, I'm always adding 6. So 6. And that's going to give me my nth term, which is 96. So this is an equation that I can solve. So I'm going to have 96 equals 12 plus 6n minus 6 when I distribute the 6. So 96 is equal to, so 12 minus 6 is 6 plus 6n. So 90 equals 6n. So n is equal to 15. So this means that this was the 15th term. Okay, so same idea, just a little bit different. It's asking for a different thing. Okay, so yesterday we learned about Gauss. Remember Gauss rhymes with mouse? He's the little boy that was like 10 years old, got in trouble. Had to add up the numbers 1 through 100. Right, so I drew this out on the board yesterday. And what he did is he said, okay, there's 100 numbers in the list, so that means that there's 50 pairs. And those pairs are all 101. So he took the number of numbers, he divided by 2 to get the number of pairs, and then he did the first term plus the last term to figure out what they all added up to be. So this always works as long as you have an arithmetic sequence, as long as it's the same thing added to each number. Okay, so the formula is S sub n, so that means the sum of the n terms is equal to n over 2 times a1 plus a sub n. So when I talk about n over 2, that's the number of pairs. And the a sub 1 plus a sub n, that's the first term plus the last term. Okay, we call this the nth partial sum. I'm adding up n items. So number 1 says find the 16th partial sum of the arithmetic sequence. So I want to find the sum of the first 16 items in this list. Okay, so as I start setting it up, I have the sum of the 16 items is going to be 16 divided by 2. That gives me my number of pairs, so 8 pairs, of the first term, which is 0, plus the last term. But then I'm stuck because I don't know what a sub 16 equals. I need that. I need the last term. Okay, so that's when this is a two-part problem. You need to go off to the side. And I do this a lot when I write like the keys for your study guide and so on. Like I start solving the problem and I'm like, oh dang it, I forgot to find the 16th term. So then I go off to the side and I find the 16th term. So that's okay if you do that. So the 16th term is going to be a1 plus 15 common differences, just like what we were doing. So a1 is 0 plus 15. What's d? How much am I adding? 12. So I'm going to have 15 times 12. So I get 180. Is that right? So I'm going to have 16 over 2 is 8, and then I have 0 plus 180. So the sum of those 16 terms is 8 times 180, which is 1440. Okay, makes sense? All right, so let's try another one. So I think the next one says, find the sum of all the multiples of 4 from 4 to 404. Okay, so multiples of 4 are 4, 8, 12, 16, right? So I'm going to have 4, 8, 12, 16, dot, dot, dot. And I'm going to go all the way to 404. Who can tell me how many numbers are in this list?
101.
Good, there's 101. And the reason is because this is 4 times 1. This one's 4 times 2, 4 times 3, right? So the very last one is 4 times 101. So if I divided all of them by 4, it's really just the numbers 1, 2, 3, 4, 5, all the way to 101. There's 101 numbers. So my n is 101, so I have the sum of the first 101 numbers. And Gauss actually proved that you don't need an even number of numbers. So when I do 101 divided by 2, I know it doesn't come out evenly. So I can't say there's a set number of pairs. But what happens is, like in the middle, let me do a basic one. Like if I have 2, 4, 6, 8, 10, like if I did something like this, 2 and 10 make 12, 4 and 8 make 12, but 6 is all by its lonesome. It doesn't have a pair, but isn't it just half of a pair of 12? Does that make sense? So what happens is when you do this, you get like 55 and 1/2 of a pair. So it works out. Okay, so I have 101 divided by 2, and I have my first term plus my last term. So in this case, I was given the last term. So I have 101 over 2 times 408. You could reduce the 408 and the 2 if you want to. So 408 divided by 2 is 204. So when you do 101 times 204, what do you get? I'm going to do it for me. 20604. Yes, that's correct. Let's do that without a calculator. Yeah, good. You just do it on the page. Okay. So next one. I always update my notes every year and I put like new names in. I don't know who Adam is. Like I have no Adams this year. I don't know. Was there an Adam that was here and left? I don't know. All right. So anyway, so Adam owns a car dealership. He spends $18,000 on advertising the first year. And then he wants to increase his advertising expenditures by $1,400 each year. Okay, so it's kind of like he spent $18,000, and then the next time he spent $19,400, blah, blah, blah. So we want to find how much he spends on advertising during the first 9 years. Okay, that would be an easy one to do without these formulas. You could just find what he spent each year and then add them all together, right? It wouldn't take very long to do. Okay, but we'll go ahead and use the formula since this is what this section's all about. So we're trying to find the total amount of money he spent after 9 years, S sub 9. Okay, so he has 9 divided by 2, and he has his first term, which is 18,000. But we need that 9th term, so A sub 9. We don't know what that is. We need to find it. So I go off to the side and I say, well, the 9th term would be my first term, but I'm going to add on 8 of those common differences. So my first term is 18,000, and my common differences are 1,400. So A sub 9 is 20, what is it, 26, 27,000 something. You're computing. I need to get my calculator. You got it? What is it? I'll get my calculator. Okay, good. 29,200. All right, so I do 9 over 2 times 18,000 plus 29,200. So when you find this number, so I do 9 over 2 times that sum, I get $212,400. So that's how much he spent total over those 9 years. Make sense? All right, any questions about arithmetic sequences? You definitely understand the pattern. You can go from like the 10th term to the 25th term. You're good with that? Okay.